Hi. Can you guys hear me?
Hello, can you guys hear me?
Yes, can you hear us?
I can now. I think I had issues with my Bluetooth.
Okay. Well, we got you, so go ahead.
Okay. I think it should work back again on my Bluetooth. You know, the home office is a little struggle if I don't have it on. Can you hear me?
Yes.
Okay, well, it's not working. Okay, so, well, I'm guessing you did the introduction. I didn't hear anything, but thanks a lot, Jean. And thanks everyone also for being here. I wish I was there in beautiful San Diego, but you know, a lot of things have made us impossible to travel. So I've decided to give this presentation from abroad, if I could say. That being said, I very much look further to shake hands with you all, perhaps at the next conference. So today I'm actually here to talk to you about the trends in the thermal transformation technologies. And the second part of the presentation will deal with how to select the best technology for your project. So I would jump right into it, if that's okay with you, Jean.
Yep, go ahead.
Awesome. So just a quick overview. We're going to look at the technology offer really quick on the USA and Canada landscape right now. Then I'm going to talk about why we should go through a technology evaluation, or why it is consider a bunch of criterias when choosing a technology. And at the end, we're also going to talk about, well, I'm going to present some examples of technology characteristics that are important to take into consideration. And we'll have a period of questions. So I hope that you guys will ask a lot because I'm here to answer. So really quickly, I know most of you already know this, but when I mean thermal transformation technologies, I generally mean pyrolysis, gasification, or torrefaction. So this is going to be my focus for my talk today. Pyrolysis being, the heating of generally carbon-rich materials in the absence of oxygen between, I guess, in Fahrenheit 660 and 1650 Fahrenheit. Gasification, on its part, has perhaps more level of oxygen generally than pyrolysis and tends to operate at higher temperatures. And this is just, really broad overview, just in case someone isn't aware of these. And then torrefaction is a kind of a low temperature pyrolysis, so it also has very little amounts of oxygen. And in all these processes, we can transform carbon-rich materials, including biomasses, which is perhaps the most transformed through thermal transformation technologies, but we can also transform things like plastics and tires and carbon-rich materials made from hydrocarbons, for example. So really, really quick background. So at the firm, some of you may know us, we're consultants, we're specialized in thermal transformation technologies, and we always keep a tab on the technology offers that is out there. So I'm going to present today a bit of an overview of what's out there in Canada and in the US more specifically. So in our recent analysis, we found more than 100 technologies in those, three broad categories that are at almost commercial level of development. So that's generally on a scale to 1 to 10, it's a 7 and over. And we see that we have more in the States than in Canada, but not so much. And I want to make sure also I precise, these are technologies that we've accounted for that have offices in Canada or in the US. So we're aware that there's a lot of other technologies, for example, in Europe and also in Asia. But if they don't have an office or headquarter in Canada or in the US, we didn't count them. So there are at least 104. We know there is more that have those in Canada and the US. It's just to show you how many technologies there are. So oftentimes people come to me and they say, well, I only found 12 pyrolysis technologies available on the market. And I say, oh, perhaps you didn't dig deep enough. And most times what happens is those technologies, they remain low key until they have really solid, multiple solid facilities operating. And some of them, they actually wish to remain low key kind of forever. So what we've seen is that the majority of them are in the pyrolysis sphere, as you can see on the right here. And majority of them are also made for large capacity. And when I say large capacity, it's to process over 10,000 metric tons of waste or feedstock per year. And that's consistent throughout USA and Canada, as you can see on the bottom right. And well, part of this, the reason why the technologies are developed so large is because there's a demand for large, I guess, supplies. A lot of time in industries, we get some demand. Oh, can I have this type of product with these specification? We say, yeah, that's great. It's available. And then they say, I want a large amount. I want 50,000 tons of this product per year. And what happens is there are not a lot of technologies that are right now established, and actually I should say operations that are right now established that can do it. And this is why we've seen that, and we think that technologies have changed the way they're doing and have focused on establishing larger production, and of course also for an economies of scale. So overall, we see that small technologies are not nearly as frequent as large technologies as they are available online right now, on the market right now. Now, there are quite large differences between the USA and Canada in terms of what technologies are offered on the market. The biggest that we see is that American technologies tend to be focused on the production of gases. And when you think about it, it's actually not that surprising, because in Canada, we see that our electricity is so low. I can buy electricity for 10 cents a kilowatt. It's not the same reality in the United States. And here I can buy a lot of renewable, a lot of hydroelectricity more specifically, at least on the East Coast and the West Coast, that is very cheap. In the States, there is a need to find other types of energy sources that are considered green or renewable, and that can provide gas, especially gas. And so there's a big kind of demand for gas. And this is why we believe the technology manufacturers are driven towards gas making technologies, which can often be pyrolysis or gasification, but not so much in torrefaction, which mostly make solid materials, solid products, apologies. In Canada, we can see kind of a reverse. It is in fact solid products that are prioritized by all of these technologies. And one of the main reasons why is because we have so much, biomass available. So feedstocks that are made of hydrocarbons, like tires, like plastics, they don't make a lot of solid product, even if we wanted to, right? They make a lot of liquid products. In biomass, this is where we can make the most solid products. And in Canada, we have a lot of biomass. We have a large forestry industry that generates a lot of waste, which is why we believe partly we see this availability in the technologies landscape. In addition, we have a lot of industries here that require solid products. For example, a lot of coal using technologies. But now with new regulations that are coming into force soon, all those industries that have been using coal previously need to turn themselves towards alternatives, green alternatives. And one of the answers to this is biocoal, which is why we're seeing this. So what is happening overall in the market? Technologies right now are getting a lot of demand. I speak to technologies every day, and it seems that they're all kind of overloaded with demand from potential investors and potential, off-takers or our partners, and they want to be involved in those projects generally. So it takes a lot of their time, but this is a really good thing because it means that the industry is actually, getting more recognized, and investors are approaching technology manufacturers. And so are project developers and the governments too. And a lot of investment have come from, well, a lot of investment, I shouldn't go there. I should say there is quite a bit of investment right now that is coming from entities that want to invest into a project that will allow them to offtake the entirety of a potential carbon credit generation. So that's a subject that I know some of you have asked questions earlier today. I'll be happy to answer some questions, but it's just to kind of position you. We've had a lot of contact with technologies and other types of investors that wish to invest to offtake perhaps carbon credits over the actual pyrolytic product like tobacco or the liquids that are coming from these wastes. So it's quite a focus on the market right now, and it's making everything move faster because there is an extra revenue stream, and it's making business model more attractive. Now, in terms of the feedstocks, generally only biomass can yield carbon credits in the voluntary markets at least. But what we see in terms of development of new technologies is that technologies to transform MSWs and to transform plastics and biosolids, so residues that have perhaps been overlooked over the years compared to biomass, are popping up more. So there's more technologies that are going to come on the market to treat these wastes that are causing more and more problems, both for municipalities and governments and for industrial generators as well. So that's kind of a quick overlook of the market. I know I mentioned a lot of things, but I want to get now into and how to choose the best technology for a project. And so some of the aspects that I treated earlier are important to consider. And what we'll see in the next slides is what other criteria should we consider to make sure that we have the absolute best technology for profitability, for optimized operations, et cetera, in a project. So the first thing I'm going to mention is, why is a technology evaluation so important? It's important to go through a technology evaluation and not just pick the first one on the side, because they are so expensive and because there's quite a lot of risk, to purchasing a technology or getting involved with technology. Some technologies say that they're super ready to go commercially and to produce at full speed, when in reality, you realize when you're installing it and where you're running trials that they're not so ready. So it's quite a risk related to that. There are hundreds of options available, as I just mentioned previously, and not all of them are suited for every project, right? Some say they can only produce transform plastic. Some say they can only transform biomass. Some say they can transform it all. We have to know exactly what their capacities are in order to be able to have an optimized project, both in terms of financials and operations. And they must be able to deliver for the goals of the specific project. The last reason why I'd say technology evaluations is absolutely primordial is because it reduces risk for investors and insurers. A lot of insurers actually want to make sure that there is a technology evaluation that has been done, because they don't want to insure a project that hasn't gone through technological due diligence. There's been a lot of failure within this space in the past, and now investors and insurance are more and more aware of it, but they're also getting more and more demand for some financing and some insurance. So they want to make sure that when they accept, to work with project developers, that the project is solid. So how do we go about doing this technology evaluation? It's more than just considering, can this technology take the tonnage, and can this technology make, biodiesel? It has to go beyond that. So generally we base it on 4 criteria: project-specific criteria, technological criteria, financial criteria, and operations criteria. And some of them, criteria kind of fit in both categories, in 2 or more categories, but they're really important to consider. So in project-specific criteria, we have to think about, what's the goal of the project? What is the ultimate goal of the project? Is it to transform a residue that is costing me hundreds of thousands of dollars to landfill a year? Or is it to make a product that can displace a product that I'm using that, the price is increasing or the supply is getting lower? We have to think about it because that will impact which technology we're going to choose. Now, feedstock is, of course, very important in the products we want to make as well. And project specific, we also want to think about the land zoning, some permits. Some technologies are quite small and only require, appliance type permits, whereas other require industrial zoning and, thorough environmental operation permits. So these are things to keep in mind. When I talk about feedstock, again, it's more than just, oh, I'm transforming wood, I'm transforming plastic. We have to think, how much humidity would I have in this material, and how will it impact my operations? You know, do I need additional equipment for that? Can my technology actually take in 40% humidity in the reactor, or is it useless because we're going to need to input more energy anyways? We also have to think about the amounts of contaminants, and in contaminants, it could be chemicals, but we could also think about sand. So a lot of people say, I want to transform, bark that is just underutilized, I guess, worldwide. But they don't think about the fact that bark has so much sand into it that it can damage certain types of reactors that are not made to handle that type of waste. So things to keep in mind. Products to be generated. We have to know where we're going in the markets. Okay, a biocoal to replace fossil coal in an electric power plant is not the same biocoal that I'm going to need for steel making. And different technologies don't necessarily do both. They could do one or the other. Sometimes you can do both, but we have to make sure that we know where we're going before we're choosing a technology, because so much depends on it. Another point is, if I want to generate carbon credits, okay, that's all good. Can my technology generate carbon credits based on different methodologies? What type of carbon credits do I want to generate? Some technologies have already been through the process of, accreditation and generation, so that we know in advance, oh, this methodology could be very interesting for my carbon project, right? But some technologies haven't been through it. So do we determine eligibility? We have to, if that's one of the key, elements of my business plan. We have to. Now, technology criteria. I mentioned feedstock already, but of course we have to think also about the tonnage of the feedstock. Small technology versus a large technology, we won't have the same capacity, quite obviously. Types of reactor, I'll talk about this a little further. The included equipment that's included or needed. Some technologies will say, my technology costs, I don't know, just round numbers, $10 million. And okay, that's fine. And then we go see another one and they say, oh, I'm only $2 million. Oh, that's great. Some clients come to me and they say, well, I want the one that's $2 million. It's so much cheaper. But when I actually look at the spec and we go through this technology evaluation, you realize, well, the $2 million technology, it doesn't have a dryer. It doesn't have an oxidizer. It doesn't have any conveyors. It doesn't have anything except perhaps a reactor and some heat exchangers. And so you have to think, how much is it actually going to cost me to add all these equipments? Maybe it turns out that the $10 million technology is cheaper. In the same way, we have to think also about the materials of a reactor, how long you want it to last, and what are you transforming, and can the material that makes the reactor handle this type of feedstock that you're putting into. Security features are extremely important, and people sometimes forget to ask. Here in North America, we have, of course, a lot of safety regulations that need to be put in place, and it's really important. But some technologies go above and beyond to ensure that if there is an explosion, for example, it will protect the workers, yes, but perhaps it will also protect the machine, something that not all technology do. In terms of automation, I also mentioned this just in the next slide. So we want to think about products. I mentioned that earlier. But what about the yields, right? If someone says, well, I'm used to handle oil because I have a refinery and I want to make, bio oil, well, we have to make sure that the technology that we can, tell them to purchase, or rather suggest for them to purchase, actually makes the most oil at the highest quality that, or rather fits the quality that they require. So now you see in the temperature range, these are really, kind of rule of thumb ratios. But if you want a technology that will make oil, we can't go under 300 degrees. So we need a reactor that has materials to go over 300 degrees Celsius, has perhaps a condenser attached to it, and is used to dealing with things like tar. So again, part of my criteria to consider when I'm running a technology evaluation. Types of reactor. I said I would talk about it. Here it is. There are a bunch of different types of reactor. You know, there's not really one better than the other, but they all have their own particularities. Some of the most common reactor are the augers, so the endless screws, which they kind of go around and they're pretty robust. It's pretty good, but we know that after a certain amount of years, we're going to have to change the screw. That's pretty standard. In terms of a rotary drum, they're really robust. You know, also they're all good reactors, but perhaps they give out a product that's less homogeneous than a fluidized bed, for example. However, a fluidized bed is not so robust. More things could go wrong in the fluidized bed that would mess up your whole operations. So you want to think, okay, I need absolutely homogeneity in my product because perhaps I'm supplying an industrial client and he needs to make sure that he gets the same thing consistently over time. But what if, you know, there's some sand in my reactor? Will that mess up the entirety of my operations? So perhaps I'm better to go with a rotary drum since my client doesn't need that strict of a product through time. Those are things that we have to talk about. We have to at least acknowledge that they will impact operations and that will impact finance, right? In terms of batch versus continuous systems, there are not so many batch systems that are out there. Most of them are continuous, and it's a good thing in a sense because continuous system allow us to take a lot more feedstock and to transform a lot more material in a certain period of time. But batch system are a lot more, again, robust. If you have perhaps metal in your batch system, chances are it's not going to mess up your whole chain like in your continuous system. Now, again, you can choose to have, you know, additional equipments like magnets to ensure that you're getting the metal out. But if your goal is to perhaps reduce the volume of things you're going to send to landfill and you don't have a choice but to send it to landfill because it's heavy metal contaminated, then maybe a batch reactor is better for you, right? Again, depending on the type of tonnage. And as I mentioned earlier, when we're evaluating the price of a technology, we want to make sure that we take all the equipment that is included into consideration because those are also quite expensive. So in terms of operation, I don't really have a slide on this. It's pretty straightforward. We want to make sure that we can get the permits for it, that, you know, it's good. We want to make sure in terms of operators that we can hire the manpower that we need. Some technologies require very specialized workers to work on their units, whereas other technologies, they say, well, anyone who, you know, doesn't have any specific qualification can figure it out with our training. And it's quite important. It's going to make a big, you know, jump in your in your OPEX, right? If you have to pay someone $100,000 versus 50, there's a big difference. Lifespan. I mentioned this a little bit earlier with the materials. There are some situations when you think about, for example, a plastic feedstock that has quite a bit of PVC in it. There's not a lot of technologies that accept threshold of PVC over 5% of total materials because it creates very corrosive products like, you know, example, HCl. And a lot of metal, you know, a lot of materials that make the reactor can't take it. There's going to be corrosion and the lifespan is going to decrease significantly quicker. So all of these aspects, they relate together. They all influence each other and how we should choose a technology. Financial criteria and perhaps also operations. I may have made a mistake, but where it comes from, this is very linked to potential technical support. If I have a technology, you know, we're from Quebec, I know the black sheep of the Americas and all, but if I have a client in Quebec, you know, he only speaks French, he's worked in machines his whole life, he's very good at doing all of that, but he needs support from technology that's applied to him. Well, if he only speaks French, I need to make sure that whoever they're buying the technology from can actually respond to his demands, whether it's repair or maintenance or, you know, changing a whole, I don't know, whole piece of the technology or giving some extra training. We have to make sure that we can answer to the demand of the client and that, the technology that you're buying isn't actually just gonna leave you there and not be able to answer you in whatever language you speak. It's really important. Sometimes some people forget about those things. Next, some financing. Some technologies, they have access to a lot of financing. Again, we're from Canada. We have a lot more, I'd say, grants and funding opportunities from the government, but also in the States, some states will give out financing for technologies and pilot plants, but they'll give a lot more money out for technologies that are local. And when there are two technologies head to head that, they would both do a very good job, but one of them is a local technology and the other one is not. Generally, we tend to say choose the local technologies because it's going to bring you, some financial advantages, and also what I just said, some probably technical advantages in terms of support and maintenance and all that kind of service outside of it. Next, business model. I'll actually talk about this a little later. And in terms of risk, well, of course, we have to consider how much experience a technology has. Some developers, they have, tens and tens of technologies out there that are functional, that are working really good. You can call their clients and make sure that everything's going well. Some technologies, they don't actually have a client. Their only client is, well, it's themselves, it's their demo plant. In this case, there is, of course, more risk, financial risk, technological risk related to that. So by doing a technology evaluation and a due diligence, probably too, we can make sure that we mitigate those risks and that we cover ourselves. So back to the insurance that I mentioned earlier, we want to make sure that if we choose a technology that's perhaps less proven, that we have this technology evaluation due diligence to support our insurance. So I mentioned after sales services, some technologies say we don't include anything, okay? Some technologies say, I'll include it all. I'll train you guys, I'll commission a system, I'll even build the system, and you have, X years of warranty, and I'll do the maintenance. Some technologies offer it all, some technology offers nothing. And sometimes it's overlooked because you think that you don't necessarily, need it, or it's not really big advantage. When you actually think about it, there's a lot of costs related to all of these factors. So it's very important to take into consideration, and in consideration of what you already have and what you already can do. For example, remote control is extremely appropriate if there's something that happens in the facility that makes it, not possible for the operators to do something about it. Then someone can call the technology center, for example, and they can take control of the technology remotely or troubleshoot it from afar. Those are the type of services that we see from a lot of technologies that have a lot of automation in them. Business model option. This is quite interesting because historically, a lot of technologies have only wanted to sell their technology. Just I'm selling. I'm not interested in producing anything. I'm not interested in doing joint ventures. They only wanted to sell. But that's, the mind is a little bit, it's changing. We're seeing more technologies want to be involved. As I said earlier in the first part of this presentation, a lot more joint ventures. So technologies could go up and say, okay, I'll finance my technology, you be the operations, and you profit sharing, you'll start buying me out of it. So this decreases the risk a lot for project developers. It ensures that it makes the technology clients very comfortable, and generally it yields successful projects. And there's other types of business model, but whatever you feel comfortable in doing, you have to make sure that the technology you want to choose also feel comfortable in doing. Because if you say out of the bat, I just want to do a licensing, that's all I want, some technology will say, not so much, even if it was the best technology for you. So these are criteria that we have to take into account from the start of a technology evaluation. So that kind of closes my technology evaluation section. Now I'm going to show you just quickly some examples of technologies for biochar production. Now I chose biochar production just because it's quite easy to put the variability out there, but this could be done for other types of technologies, right? So we see in reactor type that they can be very different. That feedstock, there's a lot of woody material because that generally has high carbon, but we can take a wide variety of things. We can take biosolids. Some will be, specialized in taking biosolids. Other will be only exclusively taking clean wood from forestry operation. None of that C&D, nothing like that. So each technology have their little particularities. And we can see that, the input, it varies a lot. You can go from a few hundred tons per year to hundreds of thousand tons a year. So the scale of your project needs to be considered. And we have to think also about how are you going to scale up your project if your project is going to scale up. Some technologies are modular. So we could just add another module and another module and another module as you evolve, but some of them are not. So if you plan on evolving, we'll definitely not go for a technology that just is a set plant and you need a whole second set plant if you want to increase your production capacity. In terms of price, which is what interests a lot of people, it's extremely variable. We can see that, for a really large input quantity, the number D technology will pay under $1 million USD. But for, let's say, 55,000 tons right beside number C, will pay around $50 to $60 million. Now, why is that? Well, it's probably quality control, the type of products that you can produce, and also the, how can I say that, the sophistication of the equipment and the amount of equipment that's included in this technology offer.
Hey, Melissa.
Yeah, sorry. Are we
We're going to have to wrap it up here because we've got to move on to the next presentation. Can you stick around for the end so that we can get to, or if you want to make any closing comments, anything that you need to address that you maybe haven't done at this point?
No, this was pretty much my last slide. I'm so sorry. I just wanted to say after this that you guys can ask questions. I'll stick around. Feel free to answer anything.
All right. If you could stick around, great. We'll get back to a Q&A. We'll try to wrap it up with Q&A panel at the very end, if that's okay.
All right. Awesome.
All right. 5-minute card doesn't work for Melissa. She can't see it.
Sorry, I didn't see it.
All right. So we're going to move on into the program. I'd love, that was a great overview, Melissa. Thank you. Getting an idea of what's out there in the marketplace, how you select a project. Now we're going to get into the real case studies, the projects you can actually see. That's one of the problems that we've had here, is many of you know, is be able to go out and kick the tires and actually see these projects in place. So our next presentation is going to be talking about the Juno technology and innovative landfill diversion solution. And our presenter is David McConnell. He's the Business Development Director for Georgia Pacific and the Juno technology. So David, I'm going to turn it over to you, sir.
Okay, well, I appreciate the opportunity to present our Juno technology. It's a little bit different than a lot of the technologies that we've talked about so far. So this ought to be interesting. As soon as I figure out how to run this. I'm on the big button. So, one of the things we always talk about is, the global footprint of waste. I mean, there's a tremendous amount of waste that's generated, across the world, and World Bank estimates about 2 billion tons are generated annually. And by 2050, they're going to go to 3.5 billion tons. And a lot of that material, as was noted yesterday, in the United States ends up getting landfilled. About 140,000 tons, I believe, was the presentation yesterday. And when you look at, what the waste makeup is, these products really, they're resources that we should be taking advantage of. And there's a tremendous amount of different technologies out there that are under development, that have been developed, that, we really see that you can take advantage and recover a lot of these in different ways. And one of the ways that, I wanted to talk about is the Juno technology. And the Juno technology really is just one piece of the puzzle. As Georgia Pacific started to develop this, one of the things that they identified in going through this is, we're a paper and wood company, really is what we focus on. They identified really that there's a lot of different other streams that that can be resources that can be captured going forward. The initial thought process was we were focusing in on the fiber and how can we increase the recycled fiber material that we're putting into the paper products that we're producing. But then as they went through the process, and I'll talk a little bit more about that, but you've got MRFs that you can put on the back end. You've got anaerobic digestion that can be included. And then you also end up with some residues that can go to waste to energy.
Got a little bit of delay.
One of the things, Georgia Pacific started their analysis back in 2010. And the way they really started is there was an interest from one of the companies that we own, which is called Dixie, and they produce coffee cups. And those coffee cups are poly-coated and they do not get recycled as much as everybody would like to see them recycled. We just started recycling those within Georgia Pacific currently. So that's where they started looking, doing the evaluation, and they identified that in the United States, 25 million tons of paper actually gets landfilled on an annual basis, was the estimate that they had. So they started doing some research at one of our laboratories and actually discovered that, through some of the processes, we actually could recover that fiber material and incorporate it back into our products that we manufactured. So in 2013, we developed a pilot operation that can handle about 6 tons per day. It's a small autoclave system that they put in place, and they actually manage a variety of waste out there, really focusing in on commercial waste, which is a lot cleaner than residential waste. So that's kind of an interesting part of our overall story here. So once they developed that, they decided in 2018 that we're going to move ahead and build our own commercial operation, which we've constructed the commercial operation. It's in Toledo, Oregon. That's a very, very small mill facility, mill city. It's located next to one of our containerboard mills. It's about 150 miles south of Portland, Oregon. So when you look at the Juno technology, really, we're focusing in on taking in commercial waste out there. And we've actually switched in our processing residential waste currently, just trying to get the volume that's required to feed our commercial operation. And we go through a sanitization process. So it's basically a Juno clave that we feed. It's a batch operation that we feed our waste product into. And our product currently, since we are at a containerboard mill, we do bale and wrap this material because they did not want to receive raw garbage at the facility. So we feed these bales. Approximately 25 tons of material goes into a batch. We apply steam and pressure to it, so we sanitize the waste. We don't sterilize it because we're at low severity. So we sanitize the waste and we break it down, and the food waste that's contaminated in it really starts to break down and becomes more of a liquid. So it's almost just like putting a big pressure cooker is really what it is, that rotates to where it starts to break down the material. And once that material gets broken down, it looks pretty much like a porridge that's coming out as we take it out of the autoclave. And then we go through a wet separation process. And this technology is really where we have our IP in there. And it's basically developed from our OCC pulping process. It's a major washing and screening process to where we're screening out all of the contaminations that we don't want and collecting the fiber material. And we take that fiber material, and since we are located at our containerboard mill, we can take that fiber material with water and we actually pump it right into our OCC pulping operations currently, and been very successful in processing that. One of the things that was identified when they were doing the pilot is as that food waste goes through this process, it breaks down and allows us to generate a lot more energy than just doing anaerobic digestion on direct food waste. So that's been very, very positive from our standpoint. And then, so once we take the fiber material, that obviously goes to our OCC pulpers, as I mentioned, and then we're producing, at this facility, we're producing boxes on the back end. And then you have the residues that are coming out, and that's where we're separating out the metals. And we're collecting all the metals off of that, and that's just through simple technology. And we're looking at, okay, now that we have these other residues, there's a tremendous amount of plastic in there. So our next step really is to capture that plastic and determine what can we sort out, what has a high commodity value that we can really reuse and resell, and what is mixed plastics and what can we do with that mixed plastics. So we're really in the evaluation point right now of, what is the next steps with those mixed plastics? Can we create an engineered fuel and send it to a cement kiln to be processed there? Or should we be looking at pyrolysis, gasification? Georgia Pacific is owned by Koch Industries, and they're doing a tremendous amount of research on all of these different new technologies. So that is the next phases that we have, is really what are we going to do with the residues to make them a resource to move forward and take advantage of them versus going to landfill. So the overall process really, it fits into, the current system of collecting waste out there. And basically the initial focus, as I mentioned, was on commercial waste streams, a lot cleaner than residential waste streams. So as we go through, we want to continue to recycle. Georgia Pacific, is one of the largest OCC recyclers in North America, as well as we broker a tremendous amount of other recycled products. So we're really looking at trash and managing that trash material. And once we can collect that and it goes into our process, basically it's very, 4 simple steps. I wouldn't say they're simple, or our technology crew wouldn't appreciate that. But it goes through the Juno clave, and then we wash the material, and then we separate out the material through our overall screening process, and then we can sort the material as it's coming off of the back end of the wash trommel. And then, of course, our initial focus is really capturing that fiber and making sure that we're getting a quality fiber that can actually be used in producing our cardboard, which we've been very successful today since we've been running this operation since March. So we are in ramp up, but we've been feeding that into our paper machines and producing that, collecting metal. And then our last stage is really identifying what can we do with the plastics and start separating those. So if you look at, the typical outputs, our target really at this point is to divert and recycle 70% of the waste stream. So that is capturing the fiber material, that's capturing the metals on the back end, and that's really diverting the organic materials in the water that we're generating out of that and recycling that. Future is to move that up to approximately 80 to 85% by coming up really with the solutions to manage the plastics and the rest of the residues that have some heat value going forward. So where do we see ourselves in the hierarchy? We put ourselves right above waste to energy. So we feel that by being able to take the solid waste, recover the fiber material out of it, puts us to where we're recycling that, and then you can generate energy from waste to energy after that point. So just a simple slide. One of the concerns that always exists out there is how do we fit into the existing supply chain? Obviously, everybody has single bins, those blue bins out there that it's going to the recycle. We want to continue that. The company wants to continue processing OCC because we're a major user of that resource. But as you go through, as the garbage gets collected and goes through transfer stations, it's really to start taking that material and processing that. So our pilot facility, as I mentioned, they built it at our paper mill in Savannah, Georgia. It's a 6-ton unit. We've been processing hundreds of batches through that. You can see we can recover metals. We've got plastics. They're slightly deformed to PET plastics that are coming out. And they always like to point out that we have the Starbucks caps that are coming off of those bottles that are in the waste stream. And we've produced paper products. And it's actually quite fascinating as you look at this trash currently that's been being dumped into the Juno clave. and the end products that they're able to produce, you've got a clean sheet of paper that's coming out of the, that can be produced off the back end once it goes through the paper making process. So our first commercial, this is our first commercial operation. It was built during the pandemic, which was quite interesting. We fired it up in March of this year. I know it says since May, but it's on 2 acres of land adjacent to our paper mill. It's really separate. Over here is the Juno clave that was being installed. As I mentioned earlier, we actually are feeding bales of waste into the facility. So they actually go up this conveyor here. Sorry, I'm not used to using this pointer here. And feed into the Juno clave that's in that building. This is actually the Juno clave. It's about 45 feet long. And it can handle about 25 tons of material. It just depends on the batch that we're putting in there. And that's really what we're testing, is really what needs to be the cook time to really get the correct amount of fiber that's in trash currently. Here's just a quick video of the different pieces that exist that we took during construction. So our preliminary focus on, the separation on the back end is really on the metals. So one of the things, in Oregon, and I mainly worked in the South when I was in the garbage business. So it's been kind of an education of gathering waste in that area. So we've been actually processing a lot of residential, rural waste that is collected by one of the local haulers there that has a franchise. So we went back and we just did some analysis of what the recovery rate, the diversion rate of their waste that they're bringing to us. And this is just a calculation that we made, that prior to Juno, they were recycling and diverting approximately 18%. And that's, that one is pretty easy to calculate. And through Juno, what we're seeing is we've increased their diversion and recycling rate up to 54%. So they probably have one of the highest in Oregon right now from a diversion from a landfill standpoint. And these are not audited, these are internal numbers that we've calculated. So we've been slowly ramping up, as we've increased the volume and feeding the material in, increasing our diversion rates. But from an emissions reduction standpoint, if you look at the EPA worm model calculation, for every ton of waste that we're putting in there, we offset about a ton of carbon going forward based on that calculation using Metro Portland's waste characterizations. So what we're looking as we move forward, the types of facilities that we're going to build is to process 1,000 tons. Yesterday, I got educated that most areas here have 500 tons on a generation. So we might have to take a look at that. And we'll produce anywhere from about 150 to 250 tons of fiber material that can be put back into the system that's currently going to a landfill. We would not build one of these operations at a containerboard mill unless one was adjacent. We built this one just to take the advantage of having steam at that facility and also take advantage of the offtake of our product. We would actually dry the fiber material and be able to ship it to any paper mill in North America that uses recycle. And of course, as I mentioned, the other recyclable opportunities that we're really focusing in on is anaerobic digestion, produce gas, which, you know, based on the conversations earlier, definitely has some value in North America, and capturing the PET and HDPE. And then our ultimate is really, are we going to go to engineered fuel, or is there a pyrolysis technology that is so advanced that's commercially feasible to really go and be able to take that plastic back into producing plastic? So just, you know, quickly in summary, it's a modular design. So as we build one of these 1,000 ton per day facilities, we would actually put 3 to 4 autoclaves into the system, so that, you know, it would end up being, it's a batch operation, but it would be more consistent and, you know, continual operation. And also it would take our capital and reduce it down, as you would not need all the auxiliary capital that was mentioned earlier in our operation. So thank you very much.
Let's do this. I know we've got some questions. Norbert, you got a mic back there? I want to try to grab these questions as they come in. So if everybody has one, raise your hand and we'll bring a mic to you.
Thank you for the presentation of the Juno process. Have you done any analysis and comparison between an existing MRF process where you're actually separating the feedstock prior to any processing versus the Juno process?
So really, we have not, as you know, the MRF process we want to keep in place, and we're post recycling. So really what we're looking for is taking, you know, the waste that is not going to a material recovery facility. So
I understand this is a waste that's mixed waste, right? Because in the mixed waste, if you look at it has about 23% paper.
Correct.
Total. And out of a MRF that does a good job, you will get half of that as cardboard that ready to go recycled without having to go through a process of hydrotreatment where you break it down. So at the end of the day, you really are after about 12 tons for every 100 ton of fiber-based paper that is not recyclable. I'm curious to see the actual technical economics of the process, where you actually have to take the entire feedstock and put it through an autoclave process. How does it compare to actual separation, segregation through a MRF, a dirty MRF, like a mixed waste MRF? And then whatever processing that you want to do after you separate, you extract that residual paper, you can do it through autoclave or any other process. I'm curious to see just the technical economics side by side of these two different processes. It seems to me that taking the entire feedstock and processing it through a batch process, upfront, I just intuitively just tells me there's some limitations when you go into scalability. How does it scale to 1,000 tons per day in terms of capex and compared to separation and then post processing? Post separation, you process all of the streams separately. Do you have any plans to actually look into these technical economics?
I think what that question might be related to is, for processing recyclables, the cost is anywhere from, you know, $80 to $90 per ton, right? And so have you looked at the cost analysis of doing it the way that you guys are doing it, maybe in comparison to what traditional recycling has done?
So when you're talking about traditional recycling, you're talking about $80 to $100 per ton, right? And that's material that's in your blue bin. So when you're talking about a dirty MRF, I believe your costs are going to be a little bit more elevated than that. Beg your pardon? Mm-hmm. So, I mean, from doing that, from being competitive, just from a MRF standpoint, we're definitely competitive from that pricing, from a costing standpoint. From going from a dirty MRF and trying to get that cardboard material and have it clean enough to be able to use in our facilities is not quite as easy as it seems. All right, John.
So my question was on the economics, was trying to understand your processing costs. Have you, and how are you trying to market this technology? Are you going to municipalities? Are you trying to sell it to private companies? I mean, the folks that are interested in high diversion are probably folks with a sustainability goal or something like that. So I'm curious as to, how you're marketing on the economic side, and are you actually engaged with communities, or how are you trying to sell this technology?
So we're looking at from a municipality standpoint or a county standpoint, right? And going to them that have these large goals. I mean, if you just use Oregon, for example, you've got Lane County there, which is Eugene. And basically they have set themselves these major goals on diverting from their own landfill that they own and operate to reach, those levels. So they've shown some interest from that. We've talked to many businesses really that are focused more on putting in more sustainable products into the cardboard containers, for example, that they're providing their materials in. So that's really another driver. But we're working with different solid waste companies that have some interests that are really focused in on recycling to joint venture with them to move this type of material. And we've also worked with several paper mill companies, non-Georgia Pacific, that are interested in, managing and putting in more fiber recovery material into their waste streams. So it's a variety, it's probably all of the above, right? The what? I don't believe that's something we would share. If you want to know the truth. We're very competitive with waste to energy costs out there. So.
Got a question here?
So it's probably a pretty simple question, but exactly what type of fiber are you targeting? Would this be like food soiled paper? This would be like the off products that you wouldn't normally extract from a MRF process, right? So this would be like wet fiber and contaminated fibers and things like that.
Correct. So we like wet garbage, right? So the material that's, the pizza box, it's got, the grease left in it. We like coffee cups for sure, since we produce those, and we've got major interest from the major companies that we supply that want to be able to say that they're, recycling these coffee cups that just get thrown into the trash currently. So, those would be the streams that would be out there.
Last question, Gene.
Yeah, David, you mentioned the biogas. Do you have any kind of amount of biogas you're producing per 100?
I can get that information for you. I don't have it off the top of my head.
Thank you.
All right. Thank you, sir.
Thank you.
Wonderful. All right. Our next presentation, we're going to be talking about gasification. So converting waste into profits and products with the FastOx gasification. Mike Hart, who has spoken here many times before, as well as David, is with Sierra Energy and also one of our sponsors. So Mike, take it away, sir.
Thank you all very much. Appreciate you all coming here today. FastOx for fun and profit. I'm using the same numbers Dave used as far as just the amount of waste being produced by the world. The estimate was 2.2 billion tons by 2025. Update, we already hit it. Go world. The estimates are just going up vertically. And so all of the wishful thinking that we're doing a better job on reducing waste, we're really not. It's going straight up and we need a solution. But one of the biggest issues is that when you throw away waste in a landfill, as we all know here, you create methane. And it's 16% of the world's greenhouse gases. And as you might recall, when NASA did that study of California, it's the bulk of the methane coming out of California is coming out of landfills. And so my own personal opinion, If they actually come out with a real carbon tax, every landfill in America has a negative value today based on the emissions they currently have. And if they had to pay a carbon tax for those emissions, you couldn't give them away. 86 times worse than carbon dioxide. That's the UN's numbers. And so you're talking about a tremendous impact from a climate change perspective. In fact, if you wanted to have an impact on greenhouse gases, the place you would start is with methane, not carbon dioxide. So in this space, we're all here at the WCTC, thermal waste conversion is growing very rapidly. It's a very large market to begin with, and it's growing very quickly. And there's a lot of people looking for beyond just thermal conversion, you know, incinerators. People are looking for waste value. What other things can you create from that waste? The Juno technology is a great example of that. But I mean, things where you can actually create higher value products and recycle it, taking it out of that waste stream. That market is exploding right now. So there's a tremendous amount of interest globally. Hey, that's us. So one of the solutions that are out there is Sierra Energy. We're based in Davis, California, up in Northern California. We've developed our technology, our FastOx technology, in partnership with the U.S. Army and the California Energy Commission, as well as a number of universities that have been helpful to us in developing, improving the technology. One of the key reasons why we have spent so much time on this, and it has been a very long time, as we've gone through all the developments and proofs, is that the technology is profitable. And that's a really important thing for most of the people we're talking to. Yes, you can convert waste to something of value, but can you do it profitably? So our technology appears to be a profitable solution. We've developed significant IP as we've been developing this technology. We've picked up partners around the world that'll actually implement taking this technology and utilizing it in their communities. In fact, I don't know what the number is anymore. It used to be the last time I gave one of these speeches, like 8,000 people have come to us saying they were interested in utilizing the technology in their community. It's higher than that now. This is our timeline. I'm also the CEO of Sierra Railroad Company, and that's the company that provided the initial funding for the technology over the years. We also had the Department of Defense and the CEC add additional money. As we went through the various stages of proof, building the technology larger and larger, building our first commercial facility down at Fort Hunter Liggett. In 2019, we raised a Series A for about $38 million. Cox Enterprises, BNP Paribas, and Breakthrough Energy Ventures were the folks that really, there are a number of other companies as well, but we did our initial raise back in July of 2019. And then as a result of that, we were able to expand our testing and the development of our first other system, which we're referring to as a Pathfinder. For folks that aren't familiar with our gasification technology, what we're doing is fundamentally a blast furnace. Taking this historic piece of technology where you basically put waste in the top, inject air, traditionally is what goes into a blast furnace countercurrent. The inventors of the technology realized that if you got rid of the nitrogen in air and just injected oxygen and steam, you ended up making a really good gasifier that operates at about 4,000 degrees Fahrenheit or 2,200 C. And so at that temperature range, you can pretty much take anything. I mean, the waste stream, there's very little preparation required when you're operating in that temperature range. And so very little pre-processing required, very low maintenance. It's a big metal tube lined with refractory, no moving parts. It's very scalable. You could build very large. The parasitic load in our case is creating the oxygen. And so the parasitic load is roughly 20%. So very effective. And you end up with 100% of what you put in comes out as a saleable product, either a gas, carbon monoxide and hydrogen, or liquid metal or slag. So you end up with an ability to recycle everything. I mentioned some of the advantages of utilizing this particular technology. It's a fixed bed gasifier. That's pretty bulletproof as far as a way of doing things. Putting in oxygen is a very, again, good way because it's counter current. You end up with a very high quality synthesis gas. And the stone that comes out, that slag, is vitrified and non-leaching. And one of the advantages that we've added something to what we're doing, dealing with tars. Tars are a pain. When you're doing gasification, in this case, we break it down further. So we recover that as additional energy. This was our pilot facility we had built many years ago with the Army at their Renewable Energy Testing Center. And we ran a whole bunch of different feedstocks through it, showing that these various types of feedstock would work. Tires, petroleum coke, industrial waste, construction and demolition debris, batteries, electronic waste, computers, that sort of thing. A lot of different hazardous wastes have been very interesting. Biomass, municipal solid waste, and medical waste. Those are all different feedstocks that we've demonstrated successfully using the FastOx technology. So basically what you end up with, gas rises, liquid metal and inert stone come out the bottom and are recovered. This was our commercial facility we built at the Army's Fort Hunter Liggett facility down in, now everybody always asks, they say, oh, where is it? I go, oh, it's in Monterey. People go, nice. Fort Hunter Liggett is not in Monterey. It's Monterey County, but it's out in the boonies and it's really hot. And if you've ever been in the military, you'll go, oh God, that place is hot. Anyways, that's where we're located. Really nice facility as far as they've been fantastic hosts for us. And they are trying to become a true net zero waste facility. Net zero waste exported from the facility and net zero energy imported. And they're doing a fantastic job of getting there. So as we've been running this facility, the idea is running this as an integrated facility to de-risk it for our next projects. Basically taking a variety of waste, including municipal solid waste and woody waste. We do operate in the state of California, and there are certain requirements on us about the kind of waste that we can handle just to satisfy different state requirements. But it's a relatively small facility, 10 metric tons. As far as feedstock coming in, it's about 1/4 of an acre as far as the gasification facility. And we're set up to do both electricity and liquid fuels, biodiesel. I'm sorry, no, in this case, it's just diesel. I always get that nomenclature. Some people get really riled up if you call it biodiesel. In any case, so the idea is just to accumulate hours down there, run the facility and doing different configurations to try and optimize what we're doing. Some of the future feedstocks that we're going to actually be running there in campaigns, different packaging materials, medical plastics, tires, and liquid waste, just things that different organizations have approached us with, wanting to run long runs with their particular materials. One of the nice things is that it's been a stabbing pain in the rear getting permits in California, but we did it. And so getting all of those air, water, fire waste, all of those different kinds of permits in California definitely makes it easier whenever we want to go somewhere else. And they say, hey, we're thinking about Iowa. We just laugh. It's like the permits in other locations are much more sane than they are in our own home state. So I think that actually, while it was a pain for us to go through in the first place, does make life a lot easier going forward. I'm preaching to the choir here. You all know this, but there is a global drive to try and decarbonize various markets. And with carbon tax and things like that, we see those all as being very positive drivers on the economics and the applicability of technologies like ours. Some of the things with our gasification, some of the feedstocks out there that you can put in, it does allow you to make a full circle. And that is, you can take these waste streams and turn into various products like hydrogen, fertilizer, chemicals, heat, methanol, protein, fuels, clean water, and electricity. I can read my own slides as well as you can, but what I'm getting at here is that when you're doing synthesis gas as your end product, as the first speaker had pointed out, in the United States, we go with gas because there's a tremendous amount of flexibility in gas. There's a lot of end products you can go to with that. Renewable natural gas in California is massively incentivized. And so that's one of the things you could make. Hydrogen, just from our own runs, we get thousands and thousands. We have an online calculator on our website. People run just to see how our technology would apply for their application. This is just raw data from the last 11,000 calculator runs. And what we're seeing is end product of electricity is declining as far as things that people are interested in, but hydrogen is rising very quickly. So there is a global interest in hydrogen as an end product. One of the advantages, it can be used in transportation. It's a very busy slide here talking about how awesome gasification is as a way to get to hydrogen as a transportation fuel. One of the things that we're talking about in our first commercial facility that we're hoping to build in California, one of the things that we've been talking about is taking various feedstocks and creating hydrogen as the end product for our first system. And one of the ways that we're trying to do that is with what we're referring to as the H2 Rails project, where we're taking waste streams, including railroad ties. There's a massive pile of railroad ties that are contaminated with creosote. And in the state of California, you simply can't dispose of a railroad tie. There is no legal way to get rid of it. Give it to some other state that doesn't mind is sort of the state's attitude. We're taking the position that we want to fully recycle all waste, including our own railroad ties from our various railroads. We've got a fair number of railroads in Northern California. We want to take the ties, run them through our gasifier, create hydrogen, and then feed our own locomotives with that hydrogen. So we'll have zero emission locomotives. So it's an exciting project that we're working on right now. The project that we're doing right now is there is a California Energy Commission put out $8 million. Half of that is going to our different railroads with a number of partners to create hydrogen fuel cell operated locomotives, which that project's underway. The other half is going to Shell, which will be putting in the first dual use fueling station where they can fuel vehicles, on-road vehicles, as well as locomotives all in one place. And they're doing that at a facility we own in the Port of West Sacramento. So some of the things that are coming up that'll just for us coming forward in the next year, building this first 100 metric tons per day facility. That's one of the ones that we're excited about, using a variety of feedstocks. Hydrogen as an end product, as I'd mentioned. We're starting to work with a number of early adopters. I cannot tell you, of all those thousands of people, the people who want to be serial number 2. So it's a lot of folks that are not really keen on being the first ones. So we're talking with those ones that are coming after number 2, and understandable. We do have a booth. I don't think it's number 1250, but I'm going to go with it's just down the hall there. And so anyways, happy to discuss this and answer any questions. Thank you.
You touched on scalability and I guess just the modularity of the gasifier. Can you give kind of a lower bounds of what that looks like?
Yeah. So our first facility that we built, we did it that could handle, I don't know, 4 tons, well, 2 metric tons per day. Was the first facility we did with the Army. The next one we did about was 10 and we actually were able to go as high as 20 metric tons per day. The problem is I have got like no one looking for little. Everybody is looking for big. In fact, we were going to go with 50 and my head of marketing came back and goes, this is stupid. He goes, everybody's wanting 100 at least. So we're going with 100.
Do you see markable efficiency decreases as you scale downward, or does it hold pretty consistent?
It's the thermal efficiency improves the bigger you make. It's just it's all of the outside battery limits. You know, when you're building a facility, there's just so much expense in building all of these other gadgets. You might as well go bigger. Right. And that's this. I'm coming very slowly to the same realization that every other person in our space has realized at some time or another. Dave and I were talking about last night. I don't know what it is about 300 tons per day But man, everybody in the gasification space, you always end up, they say, we're going to be building our first 300 ton per day. And it's just like, why? Why is that number magic in our space? But we're probably going to end up there too at some point.
Last question. You function as not only an operator, but also a technology provider, or solely as an operator?
Yeah. So my goal had been exactly as the first speaker had pointed out. We wanted to license. It's a lot. It makes a lot more sense. It's capital light. But there's so much risk in this space. I mean, it's almost like you're saying you're selling perpetual motion machines when you talk about gasification. You have to build one. You really have to build one at scale. So yes, in the first case, we are going to, but in subsequent cases, we really would love to license.
Thank you.
So what you're saying is you're going to go big or go home, right?
I'm going to do both.
Do you have an idea what the 100 ton per day CapEx, OpEx, how much would it cost for the per ton of feedstock for processing?
I do. A lot of it's proprietary right now. And I apologize. It's not that we don't want to share it. It's just not done yet. Because as we work through the process on our financing with our various partners and investors, we got to nail down that number. Once we do, we will come back to one of Gene's conferences and tell everybody. It is profitable, though. I guess that's the best I can say in the state of California.
All right, we got one more question here. Hang on one second.
Yes, with regard to the reference you made on the your recent searches and what people are looking for in the increase in hydrogen, was that is that search base California based, or is that globally, or what is your scope on who is making those searches?
Sure. So we get thousands of people a month go to our website, and they use our calculator and they self-report where they're coming from. And so we have a very beautiful set of slides that aren't in this deck that show by geographical region what people are searching for. And that's a global number. So that's not focused on any particular region. That's just of the last 11,000 runs. There is a climb in hydrogen. I can tell you from my own personal experience, California hydrogen is standing almost vertical. A lot of the states that have incentives, hydrogen is just going off the charts.
Very good. Thank you.
Certainly. Thank you, Gene. I appreciate it.
Yes, sir. Thank you. Very good. All right. Our next presenter is Lauren Versagli, and Lauren's the corporate development with USA for plastic energy. I actually had, this is going to be talking about pyrolysis. I got the chance to actually go see one of Plastic Energy's facility in Spain, 2019. I was over there for agricultural film recycling conference, and contacted them and got a chance to actually go see. I wanted to go kick the tires, if you will, and see one of these commercial scale operations doing what it's supposed to do. And so I am actually thrilled to have Lauren present on their technology and what they're doing. And this presentation is on upcycling, the end of life plastics. So Lauren, I'm going to turn it over to you.
Thank you, Gene. So yeah, good afternoon, everyone. My name is Lauren Versagli. As Gene said, I'm based in Denver, Colorado, and have been working with Plastic Energy the past 2 years for establishing our company's presence in the USA. Before that, I worked for Dow and for Danaher, but had been in this space looking at a lot of gasification and pyrolysis technologies. So it's really fun for me to come back on, especially from the view of a technology provider. I'm going to share a bit about Plastic Energy with you today. Sorry I can't be there in person, but definitely excited and grateful that I can present to you virtually. And I think we'll have time for questions as we have with the other virtual speakers. So feel free to chime in at the end with anything that's come across your mind as I've presented. The last thing I want to share on this slide is to Gene's point earlier, which is this is a picture of one of our operating facilities. This is the Almeria facility. Gene, I think you and I actually both visited Sevilla, but it looks quite similar. So just to give you an idea of the operating plants. There we go. I'm going to touch quickly on advanced recycling. I think you guys are extremely well versed. You've already heard a couple of technologies, well, the gasification one specifically. I'm going to talk about plastic energy. So just quickly where we're located, what we've done, and just very high level technology and feedstock. One of the things that has helped us be successful is our partnership. So I'll share a bit about that. Some examples of plastic to plastic. So end of life plastic back to prime plastic packaging applications. And then just share with you a little bit about the future pipeline and projects that we're looking to do globally. To start, I would say we are definitely in the position where we want to be a complement to mechanical recycling. So I think some other speakers have talked today about where does everything fit together in the supply chain. And we have been processing post-consumer waste in Europe that is not able to be used by the mechanical recycling facilities, but is coming through the existing waste management infrastructure. And in that geography, it tends to be a lot of flexibles and films because they are very good at sorting and reusing a lot of the rigid materials. We think it's going to be really important to continue to develop the advanced recycling technologies for a lot of reasons. One, we need to increase the recycling rates. I think there's been some proposals even by the EPA about what those could look like for the USA. Certainly in Europe, there already are some targets. And in addition, there's a huge amount of PCR, post-consumer recycled content demand from the brands of people who have signed on to pledges like the Ellen MacArthur Foundation's New Plastics Global Economy. And so the demand is there, and it's not only for just mechanically recycled material, but also for material that allows it to be reused again, like I've mentioned before, in food grade and prime plastic packaging applications, which is something that advanced recycling can do. So what we want to do is, leave this typical loop in place, which is what exists today. We expect there to be a lot of improvements. Equipment is improving. People are investing in their MRFs and trying to separate more, but there is still a lot of residual and a lot of other plastics that might not be going through the traditional MRF system that are considered post-consumer, and today are ending up probably mostly in the USA in landfill, perhaps some incineration. We don't tend to be the biggest source of leakage, but we want to recreate this loop here. Just as a point for the presentation, we call our technology thermal anaerobic conversion. So that's why you'll hear us talk about, or me talk about a TAC plant or TAC oil. It's just our brand name for the name of our facility and the name of our pyrolysis oil. A bit about who we are. Our headquarters are based in London. So we have the vast majority of our engineering staff there and all the support functions. Our operations, the two plants that we have running today are in Spain. So overall, we're a little bit more than 130 people, which is, the company has seen tremendous growth even since I've joined in the last 2 years. We absolutely consider ourselves a leader in the chemical recycling space. A lot of that has to do with the two plants that we are operating. They've been, the first one was Almeria. It started online in 2015, and then Sevilla came online, I think in 2017. So we've learned a lot operationally and certainly optimized the plants to the point where they've gone from running around 10 days a month to more than 300 days a year, which has been great because we're certainly not profitable running only 10 days a month. We've been extremely focused on plastics to plastic. So I think for about the last year and a half, all of the material that's been produced, so the TAC oil from our two plants in Spain, have been going to steam crackers for reuse as ethylene or propylene that ultimately turns into PE or PP for use in plastic packaging. The technology that I mentioned, the thermal anaerobic conversion, is patented. And you'll hear me talk about it later in the presentation, but we have some great long-term partnerships with major industry players and also other people in the value chain that has really helped us create proof points for this type of technology and advancing the circular economy. To give you just a quick, very high level flow diagram of what our operation looks like, it is pyrolysis. So we start with end of life plastics. They are fed through an extruder to do some preheating of those materials before they go to the pyrolysis reactor. There, of course, everything is heated up. The gases come off the top, pass through a contactor, which just helps with some of the final quality of our TAC oil product. Obviously, the product is then condensed and stored in recycled oils. We have 4 main outputs from the process. So we have char, we have water, we have tack oil, which is just a single stream. We don't fractionate between a diesel and a naphtha. And then we have a non-condensable gas that's actually reintegrated into our own internal process as a heat source. So it is pretty straightforward in terms of what comes out the backside. To give you some indication on what we could do with plastic waste in terms of feedstock, what you see on the right is a photo of plastic that is actually going into our plants today. The form that we use is things that are shredded. Going forward, it might not look like that. It could be a densified or kind of nuggeted product. We take the different grades of polyethylene, polypropylene, and some polystyrene, and we can't handle polyethylene, PVC, I'm sorry, PET, PVC, EPS, or category 7. I mentioned, and what you can see is that we do process a lot of flexibles and films. We can certainly take rigids. In the US, I think that might be more the case just because the way that our recycling bin MRF systems are set up today, a lot of flexibles don't make it in there. So any material that comes from that source will probably be rigids that weren't well sorted. We don't separate by polymer type and we don't wash. So as long as we're in the category of plastics, which sit on the left-hand side of that chart up there, then they're all mixed together and sent into the extruders. In some cases, we do additional pre-processing, and in other cases, our waste handler partners are giving us a feedstock that's on spec. So both are options within our plants and technology. And as I mentioned, the form of the feedstock, we can plan for that in the design of pretreatment. I thought it would be interesting. A couple of other speakers have spoken about this, the topic of CO2 and emissions. It certainly is an important topic, I think, for the industry and also for the entire value chain as we look at these recycling technologies. So we had Qantas, a company, help us create an LCA. The executive summary is online, so you can dig in a bit more if you're curious. And we took an approach where we looked at 2 sides of it. So we looked at the end of life. So, you know, what happens when the plastic is at the end of life? And we also looked at a product creation standpoint. So if we focus first on the end of life scenario, it was using plastic waste again in Plastic Energy's process, sending it through incineration or landfilling it. With the company being European, the strongest comparison in Europe is obviously to incineration. And as compared with incineration, the CO2 impact is 65% lower, even when you include the energy recovery that's that you get from incineration if you use this end of life plastic in a plastic energy plant and recover the material as a tack oil. Landfill, of course, plastic doesn't emit much CO2 in a landfill. So landfill does have a lower climate impact than using the resource again in an advanced recycling technology, but then you don't get the resource recovery. So there are some trade-offs there. If we take a look at the other view we did, which was a product perspective, and said, okay, if I have to make a ton of LDPE and I use virgin fossil fuel to do that, I use mechanically recycled LDPE, or I use tack oil to do that, what does that look like in terms of climate impact? And as compared to using virgin fossil fuels, there's a lower impact by about 50% when using Plastic Energy's tack oil as the raw material source as an alternate to naphtha. And then LDPE from mechanical or recycled sources is still a bit lower, again, with the caveat that it doesn't always make it to food grade packaging, and there can be some limitation on the number of times things can be recycled. As mentioned in one of the very first slides, we think that the combination of both the types of recycling, mechanical and chemical recycling together will absolutely reduce the environmental impact of plastics. And as more renewable energy comes online, the plants get larger in scale, the efficiency should continue to improve. And we think that these numbers will also improve in the future. The last point on this slide I want to touch on, I'm not sure, I think probably many of you are familiar with it, but the Good Company, maybe a couple months back, issued a report on looking at emissions from pyrolysis facilities. They looked at facilities which were about 55,000 tons, processing 55,000 tons of end-of-life plastic each year. That is a little bit bigger than the size plant that we would do 100 tons a day, so about 33,000 tons. But what they found is that when they compared the emissions to many of the other food processing facilities, universities, hospitals, automotive manufacturing facilities, it's very comparable to what happens and what's emitted in those other general processes. And there's a lot more detail. I'm sure these slides will go out so you can see, I have a link at the bottom if you're curious to take a look at that report in more detail. I just want to spend a little bit of time talking about our partnerships. I think this is something that has made us extremely successful and able to demonstrate so many proof points in the circular economy and chemical recycling space. So across the top, you see some of the major petrochemical companies that we have made formal announcements with. So Sabic, Total, Exxon, and Ineos. And Nestle, even as a brand owner, has jumped in and said that they're interested to work with us to help put a project together in the UK. And so you'll see that we work with a lot of feedstock providers to get our material, and petrochemical companies. I think those tend to make sense because they're on either side of us in the value chain. But we're highly engaged with converters, retailers, and brand owners who are ultimately pulling a lot of this demand through the system and making sure we're aligned with their goals and what they want to do as well. So this is, I think, some of the more exciting stuff. So when we talk about, okay, this is interesting, but can we do this? Can we see this as a reality? The answer is yes. We were the first technology company in the world to have validated certified circular polymers. We, of course, did that with a group of partners. Renewi was a waste handling company in the Netherlands. Sabic was the petrochemical company, and Unilever, Viventions, Tupperware were some of the big brands that were part of the first plastics. And this was announced back at the Davos event that the World Economic Forum does every year. It was certified and traceable through the ISCC Plus program, which I think at this point is really expanded even here in the USA. A lot of facilities and companies are becoming certified and active in that. And we tracked and traced the recycled content through the mass balance approach. This slide gives you some idea of some of the other food grade packaging that we've been able to create. The first one here, and the first two actually were mentioned on the previous slide. So Unilever used their Knorr pots, which is like a lot of soup and broths, and their Magnum ice cream containers with recycled content. Tupperware made some straws. I think starting next year, Mondelez is going to put it in their Philadelphia cream cheese. The next example is really cool. That's actually like a full closed loop example. So what happened is a lot of the films and bags that were returned to the Tesco supermarkets in the UK were sent to us for conversion to oil. We sent the oil to Sabic for conversion to pellets, and Sealed Air made it back into film, and then Bradbury's cheese used that material and it was sold again into Tesco stores. So that was a great example of really closing the loop. And then the last two, you see a wine cork and some skincare products that are also used using tack oil and the ISCC Plus certification. To give you an idea of where we are with our project pipeline, you'll see on the left, the two locations that are boxed are the ones that are operating in the south of Spain. We have the pipeline to do 2 projects in France. One of those is with ExxonMobil and the other is with Total. We've broken ground on the project with Sabic in the Netherlands, so that is moving along. Viridor and Nestle are working on a project in the UK. We have a couple pieces of activity in Southeast Asia, so with Petronas in Malaysia and also West Java in Indonesia. And we're working also with Ineos to determine a location in Europe that will work for them. Hopefully we'll have some yellow dots here in the USA soon, and certainly working to that end. To give you just an idea of what a plant and project structure looks like, so probably the 3 most important legs of the stool are a feedstock provider, of course ourselves converting it, and then a petrochemical off-taker who takes anywhere from typically 100% of the tack oil they're interested in taking. Our plants are, the generation of plants that we are building now will be 100 tons a day. So we base that on 330 days of operation, which takes you to 33,000 tons a year. You can see how much tack oil is produced from that. It's about a 65%, 67% yield. It takes about 7.5 acres for the plant footprint. If we need to do pre-processing, we would need a little bit more space than that. And it takes between 25 and 30 people to run that plant around the clock. Just to give you a final view of what we're looking for in North America, it is to build a pipeline of future projects here. Like I mentioned on that map, we would love to see some yellow dots, certainly in this space. And we hope to start a first project feasibility study later this year. Very active in looking for feedstock to supply potential projects. And in the USA specifically, we hope to have a pipeline of 2 to 4 of these that are operational by 2025. Again, in the US, we're still focused only on plastics to plastics applications. And we're very active in overall advocacy and information for the industry. So, you know, whether that's discussions on mass balance or discussions on the definition of recycling or helping lobby for inclusion of some of these technologies in state legislation and demonstrating what we've been able to do so far in Europe, we're very engaged on to that front. I think the final slide I have is just to show you a video, and then I think there'll be questions and then lunch on your side. So let me escape out of this and just go right to the YouTube and play it.
Humans have always developed technologies to improve the quality of living. Plastics have enabled us to reach space, have improved agricultural production, and enabled food and water to be distributed in a more hygienic way. They've also revolutionized healthcare and helped to save lives every day. However, our lifestyle also generates serious problems due to the ways in which we use plastics. With a life cycle of less than 12 minutes, the plastics that we use and throw away every day are rarely recycled and end up piling up in landfills or in our oceans and rivers forever. It is estimated that our oceans hold in excess of 150 million tons of plastic, and that almost 70% of the seafood we normally consume has traces of microplastics. If we continue in this direction, by 2050, there'll be more plastic than fish in the sea, and the situation on land will further worsen. How can we manage this plastic wave which threatens our planet's existence?
Plastic Energy has been working to find a solution over the last 10 years. And today, we have good news to share.
Thanks to a unique process, we've been able to recycle the plastics no one wants and which cannot be mechanically recycled to obtain tack oil. It's an oil which can be used to produce new plastics with a low carbon footprint. This technology reduces fossil fuel consumption used to create virgin plastic. This is not science fiction, it's not a project or a dream. It's a reality which is already up and running 24/7, 365 days a year at our plants in Almería and Seville in Spain. It allows people to continue enjoying the advantages of plastic while minimizing its detrimental effect on the environment. This is a new hope for plastic recycling, which we'd like to bring to the entire world, and a process which has made us world leaders in the circular economy of non-mechanically recycled plastic. We've created a new technology which is making a big change. A change which on a daily basis inspires and motivates our employees in London, Almería, Seville, and which will enable us to jointly make a difference in a world where using plastic will no longer be a threat. A technology which will help us look after our cherished planet. Plastic Energy, technology to recycle our future.
Okay, great. I will come back here. And that takes me to the end of the presentation, Jean. So any questions in the room, I am happy to take.
All right, wonderful. Thank you, Lauren. So we have any questions from the audience? All right, we got one. Norbert.
Fantastic. Thank you, Lauren, for the presentation. I know you mentioned that you use a good deal of flexible plastic in your process, and you had the list of the goods and the bads. But if there was one thing you could change about, the incoming flexible material that would improve your process, what would you say that would be?
So, I mean, I think a lot of the design for recyclability initiatives that are at the major petrochemical companies will help. Certain barrier layers, which are very functional and very useful for certain applications in high quantities, do create too many contaminants in the tack oil. We do process multi-material flexible packaging today, but it is in smaller quantities.
Yep.
Just a quick question first is the footprint of the facility. And also I noticed some height, a stack in one of the facilities quickly on the video, adjacent building. I tried to do the math on how many stories there were there. So maybe between 75 and 100 feet on your vertical requirements. I'm just thinking from a permitting standpoint.
I have a document of site requirements. I don't know the answer off the top of my head. I have a number in mind, but I want to double check before I confirm it back to you, but happy to do that. It's not proprietary and can certainly share it.
All right, Lauren, I think we have a question on the virtual. We're going to make them live, or you're going to ask it?
Hi, Lauren. This is Melissa from GECA. I presented at the beginning. I have a quick question for you. You said that you had 4 products, but we mostly talked about the plastics. Now, I was interested to know what you do with the other products that come out, specifically the Coke that you get.
Yep. So the char today, it has 2. It is either landfilled or it is used and sold as a product. So like I said, the oil goes to the petrochemical companies. The light gas is reintegrated. Water needs to be discharged, and then the char is either landfilled or sold as a product.
All right, thank you.
Absolutely, yep.
All right, any other questions for Lauren? Melissa, I'm going to turn it back to you. Are you online?
Yeah.
Okay.
I just asked a question.
Oh, sorry. I got a question for you. As you did your review of waste conversion facilities, how are you keeping track of the information on who's doing what? Because it's pulling my hair out trying to figure out and stay up to date with everybody.
It's really hard. It's really hard to stay up to date. And, pretty much every week we hear of someone new developing a technology. But the reality is we have a team behind us that keeps us updated on what's happening. And I mean, I can't lie to you. I probably don't know everything that's happening because a lot of it is happening behind closed doors, but we follow the media very closely. We have a very large network, and we are always aware because we do a lot of technology evaluations. So we're very aware of, how each companies are evolving. If they suddenly have an operational commercial facility other than their demo, we're probably going to know just because we have to inquire in the scope of our technology evaluation. So it's long and tedious, but it's really important for the industry. And again, I won't lie to you, I probably don't know every single one of them, but we like to keep as much as we can for sure.
All right, and I got one other question for you, and that's on the insurance side. You mentioned in your presentation about some of the on the project financing that insurance is starting to be required in certain situations. And maybe this is for you, Melissa, and Mike, and David, and maybe some other folks in the room. Are you all starting to see requirements on insurance to back projects?
Well, for my part, and I'll let Mike and David answer afterwards, but for our part, we get some requests from insurance companies, sorry, and investors for this type of, technology evaluation, or just to check a business plan because, all these companies, they're very interested in tapping into the market, but there's so much uncertainty related to the technologies, related to whether the products can actually attain the market and whether the prices of the products are realistic. Basically, people just don't know what the hell is happening in this industry, but they want to participate. So we see that it's becoming quite a requirement, especially in terms of financing. Yeah.
All right. Jim?
From our perspective, a number of investors have raised for first facilities or early facilities using some sort of insurance, like what New Energy Risk has provided. Really great product from what I've seen, but basically allows you to tick the box where traditionally you really couldn't do that with a first of its kind technology. So it's very exciting, but because it's there now, people want it. So
What's the name of the company?
New Energy Risk, if I have that correct. Yeah, they're based in San Francisco, as I recall. And they're out there looking at trying to help first of its kind technologies. And they obviously the envelope around what they're insuring is quite narrow, but it's what a lot of first of its kind technologies require.
Yeah, on the CapEx side, with all this new technology, you got to figure out a way to lower your risk involved in the projects. All right, any other questions for our panel? Go ahead, Melissa.
I was just going to say, even I'm going to add to that, some governments that are involved in some types of projects that touch, thermal conversion technologies also want to see this type of assurance and work done behind it, because now they're starting to back it up more and more, but they don't want to, shoot themselves in the foot. New Energy Risk probably provides some really needed insurance for the industry that wasn't available prior.
Maybe get them to come present next year or the year after.
This question is for David. If you don't mind sharing, how many hours is your 25-ton batch have to stay inside of the reactor?
Depending on the wet strength of the fiber material, it's anywhere from an hour to an hour and a half.
Thank you.
It's pretty good. Any other questions? All right, well, if you will all join me in thanking our presenters, especially our virtual, Melissa, Lauren, Dave, and Mike, thank you very much. We are going to now break for lunch. Give us a little extra time, so maybe go enjoy. I see the sun looks like it's finally out, so enjoy the San Diego weather a little bit before we, I think lunch kicks off right at 12:30, so it should be out in just a few minutes. Thank you.